Welcome back, Pre-Algebra. We're going to talk today about lesson 43, which is multiplying and dividing mixed numbers. So let's start with multiplication of mixed numbers. Let's say I have 2.5 right here, and I want to multiply that by 2. Let's say I have 2 people, and each of them have 2.5 boxes of something. So I can illustrate that by saying, here's a box, here's a box, and here's half of a box, right? Here's the first one. This is the 1. All right, well, here is the second. We're multiplying by 2, so we have 2 sets of 2.5. So here's another box and another box. Here's their 2.5, right? So 2 times 2.5, and then we have 2 sets of 2.5. When we combine these sets, let me put this with this, and I'm going to bring this up here. So when we combine them, that's what multiplication is we're taking the individual sets and we're grouping them together. What we actually end up with is 5. 1, 2, 3, 4, 5, because these two half parts combined into one box. They added together. So the correct answer for 2.5 times 2 should equal 5, right? How do we get that when we do mixed numbers? So there's a couple of ways that you could look at it if you wanted to try to figure it out on your own. We could say, well, I've got 2 here, but I don't have a fraction, so I'm going to put zeros in. And then you could say 2 times 2 is 4, 1 times 0 is 0, 2 times 0 is 0, so that goes away. So the answer is 4. But we know that's not true because those two halves matter. They add up to make another whole, which gave us 5. So doing it that way doesn't work. Okay, so what if we just carried that over, right? And we said 2 times 2 is 4, and then we just brought the 1/2 over because there's nothing to multiply it by. Well, that's not the right answer either. We know the right answer is 5. We've seen it come together visually. So that's not the right way to do it either. What we have to do is be able to multiply times this also. So the only way to do that effectively in mixed number format is to multiply 2 by all of the parts. So 2 times 2 would be 4. Sorry, I don't know why I'm writing another 2. Would be 4. And then 2 times 1/2 would be a 1. But the answer is not 41. So we could now just say maybe add these together would be 5, right? So yeah, we could do it like that. That is probably the only way you could do that. But what if you have 2.5 times 2.5? I'm sorry, times 2.5. How do you multiply 2.5 times 2 and 2.5 times 1/2? It's fine when it's just another whole number because you can actually see that 4 plus 1. But what about when we get to this point? We're going to have to change and do 2 times 2, 2 times 1/2, and then 1/2 times 2 and 1/2 times 1/2. That's extremely complicated. There's a better way. And the better way is to turn everything into an improper fraction, and then everything multiplies all at once. So that is what we do. We say, all right, so we had 2.5 times 2. What we do is we say 2 times 2 is 4, plus 1 is 5. And then we turn this whole number into a fraction by putting it over 1. Now everything is in a nice orderly fraction format. We'll go straight across. 5 times 2 is 10. 2 times 1 is 2. 10 divided by 2 is 5. We know that's the right answer. We've already done it. And this way works for every situation. Let's say we had that 2.5 times 2.5. That would be 5 over 2 times 5 over 2. That would be 25 over 4. Now that might not mean anything to you, but you could turn this into a mixed number. You could say 24 divided by 4 is 6 and 1/4. All right, that has a real value. You can get there by using fractions much, much easier than by trying to multiply whole numbers and then multiply by a fraction. It's extremely complicated if you do it the other way. All right, so let's jump into an example problem. So here is our first example problem, 43.1. And we have 4 1/3 times 6/5. So that's the other thing. What do you do when you only have a fraction and you don't have a whole number? How do you multiply that? So that is why we turn everything into fractions, because it makes it a standard format and there's no guesswork. So 4 times 3 is 12 plus 1 is 13. It's 13/3 times 6/5. So 13 times 6, I can't do that in my head, but you don't have to because there's a way around that. And the way around that is to factor all of the numbers on the top and all the numbers on the bottom. So we do that by drawing a line and we write whatever we can factor out on that for the numerator in the numerator. So we've got 13, it's a prime number. We can't do anything else with that. But 6 we know is 2 times 3. Now we have 3 times 5. Those are both prime numbers, so we just write them. 3 times 5. But now I see that we have a 3 in the top and a 3 in the bottom, and I can factor those out. I am effectively dividing this fraction by 3 before I multiply it. I am reducing it before I multiply it in a way that doesn't require me to whip out my calculator. Saxon wants you to think about the numbers. This mathematics wants you to understand how numbers work together and what their relationships are and how the operations affect those. And one of the ways it teaches you is to cancel or factor out and cancel really big numbers so that you can do the math in your head without having to bring that calculator into play all the stinking time. You know, there are going to be times when you need it because the numbers are just too big. But whenever you can, we want to simplify and reduce so that the math is easier. So here now we have 13 times 2, which if we double the 3, that's a 6, and we double the 2, or the 1, that's a 2. And we don't have anything else but the 5 left in the bottom. So our final answer is 26/5. And if you wanted to turn that into a mixed number, that would be 5 1/5. But this is the answer that I like in the system because we are getting to a point now where we need to start turning everything into an improper fraction. When you get to Algebra 1, we don't like to use mixed numbers anymore. Algebra does not like mixed numbers. The only reason that we are still using mixed numbers is because it gives you an idea of what the value actually is. And you're going to have to get to the point to where you see it without having to write it down. I can see that this is 5 times 5 is 25, and 25 from here leaves 1 without having to write that down. I know that's 5 1/5 just by looking at the improper fraction. And before long, you're going to be able to do that too if you can't already do that. Okay. All right, so let's do 43.2. So here I have a whole bunch of mixed numbers. I have 2 1/4 times 3 1/3 times 5 1/12. All right, so let's start by turning it into an improper fraction. 2 times 4 is 8 plus 1. That's going to be 9/4 times 3 times 3 is 9 plus 1. That's 10/3 times 5 times 12 is 60 plus 1. That's 61/12. Now we're going to factor everything to see what we can cancel. 9 is 3 times 3 times 10, which is 2 times 5 times 61 is a prime number. There are no factors of 61. 4 is 2 times 2 times 3, which is a prime number, times 12, which is 3 times 4. Now I could factor this into 2 times 2, but I know from looking at these factors up here that I don't only have 1 2, and that's going to be taken away by one of these. So there's no point in factoring this out. All right, I can leave it the way it is. So now I can cancel. I can cancel this 3 and this 3, this 3 and this 3, this 2 and this 2, and that's all that I can cancel. So when I do the math, I get 5 times 61, and that is going to be 305. And I can do that in my head because 5 times 6 is 30, but it's in the tens place, so 30 times 10 is 300, and 5 times 1 is 5. 300 plus 5 is 305, and 2 times 4 is 8, and that is my final answer, 305 divided by 8. All right, so now let's talk about division. Division with mixed numbers, we treat it exactly the same way. We factor it out first, or we turn it into improper fractions first. But division is a little tricky, right? So let's talk about that. So let's do 43.3. You might see a problem that looks like this. 2 1/8 divided by 3 2/3. So at first that looks really hard. And you're like, oh my goodness, how am I going to do that? But you can just rewrite it. Just rewrite it so that it doesn't look so scary. So this is just going to be 2 1/8 divided by 3 2/3. Now that doesn't look as scary as it did before. What we can do now is we can turn this into an improper fraction. 2 times 8 is 16 plus 1 is 17 over 8 divided by 3 times 3 is 9 plus 2 is 11 over 3. Now we know what to do. Now we know we can keep it, change it, flip it. So we'll keep the first fraction, 17 over 8, change the sign, and flip the third fraction, which is going to be 3 over 11. Now there are no factors of 17 because it is prime. 3 is prime, and 11 is prime. 8, it doesn't help me at all to factor this. So what I've got to do is just whip out my calculator and multiply. 17 times 3 is 51. 8 times 11 is 88. That's my answer, 51 over 88. That really didn't take a whole lot of effort. So don't let something that looks like this scare you. Just rewrite it to where it doesn't look as scary, to where you can attack it and not let it scare you out of being solved, right? The numbers, sometimes they get scary. It is getting close to Halloween. So don't let them scare you. They're just numbers, and you have control over the numbers. Rewrite them and master them. Make them do what you want them to do, right? Which is not be scary. So let's do 43.4. We have 4 1/8 divided by 2 1/5 times 3 1/4 divided by 5 1/2. Oh, Miss Tracy, this is too much. I cannot handle this. I can't divide and multiply and all that other stuff with all. Yes, you can. You'll be fine. Just take it one step at a time. First step. First step. Number 1, improper fractions. All right, that is the first step. Improper fractions. 4 times 8 is 32, plus 1 is 33. 33 over 8 divided by 2 times 5 is 10, plus 1 is 11 over 5 times 3 times 4 is 12, plus 1 is 13 over 4 divided by 5 times 2 is 10, plus 1 is 11 over 2. Now, what do we do when we have a division symbol between fractions? We flip the second fraction and change this to multiplication. So keep it, change it, flip it. Bring down the next one. It's multiplication, so we don't have to do anything to it. But this one is division. So we keep it, change it, flip it. Voila. Right? Easy peasy, not hard. Now we are going to factor all of this stuff. So I'm going to draw my line. 33 is 3 times 11. Then we have times. Then we have 5. Then we have times. Then we have 13. Then we have times. Then we have 2. And that's it. On the bottom, we have 2 times, I'm just going to leave that as a 4, times 11, times 4 is 2 times 2, times 11. All right. Got too much line. Now I'm going to factor out. All right, so the first thing I see is I have an 11 and an 11. And then I have a 2 and a 2. So I got rid of both of those. Now I can multiply what's left. So 3 times 5 is 15. 15 times 13. 15 times 10 is 150. And 15 times 3 is 45. 150 plus 45 is 195. All right. Now I have 4 times 2, that's 8. And 8 times 2, that's 16. 16 times 11. So I know 16 times 10 is 160. And 16 times 1 would be 16. So 160 and 16 is 176. And that's my final answer. And I know it's right. So you see, you don't want to add stuff that you want to leave it here and have to multiply it and get these big, huge numbers. Reducing it on the front end saves your brain, right? It saves your brain. And that's all we have for lesson 43. Oh, I didn't finish the steps, did I? So improper fractions first. Then if you need to, keep it, change it, flip it. As needed. That's an E. Then we factor and cancel. And finally, we solve. All right, 4 easy peasy steps. Improper fractions, keep it, change it, flip it, factor and cancel, and then solve. And that's all you need to do to solve these mixed number multiplication and division problems. All right. That's all we have for 43. Now that I've finished your steps, I will see you in lesson 44.